Let's do an example, another one with completing the square. So we have something quadratic. 6x squared plus 7x minus 3 equals 0. We're going to solve it by completing the square. Notice it's in the form ax squared plus bx plus c equals 0. So we need to figure out what a is, what b is, and what c is. A in this example is 6 because it's the coefficient of x squared. B is the coefficient of x. So in our example, we see that 7 is the coefficient of x. And then c is our constant. So in our example, it's -3. So step 1 says if a is not 1, well, first off, is a 1? Nope. Okay, so we're going to have to actually do this. Make it 1 by dividing every term by a. Okay, so we're going to look at our original equation. 6x squared plus 7x minus 3 equals 0. So this says we are going to divide every term by a. So divide by 6, divide by 6, divide by 6, divide by 6. Then we'll clean it up. So x squared plus, oh, I know you love this. This is fractions. 7/6 times x minus, looks like we have 1/2 equals. And then 0 divided by 6 is 0. So we've done step 1. Now move the constant to the right-hand side. So here's my constant. I'm going to move it to the right-hand side. So to do that, I'm going to add 1/2 to both pieces. So x squared plus 7/6x equals 1/2. Okay? Now here's the actual completing the square part. I'm going to take the coefficient of x, and notice my coefficient of x right here is different than the original coefficient of x. So I'm not talking about my b anymore. I'm talking about the new coefficient of x, and I'm going to multiply it by 1/2. Okay, so do the scratch over here. So I'm going to do 1/2 times the coefficient of x. So we have 1/2 times 7/6. See that? This is the new coefficient of x right here. Well, how do you multiply fractions? To multiply fractions, you do the numerator times the numerator over denominator times denominator. Or top times top, bottom times bottom. So we get 1 times 7 is 7. 2 times 6 is 12. So that's part A, 3A. Now for 3B, I'm going to square. So I have 7/12, and I'm going to square it, and it says add it to both sides. There's a hint right here to leave it in this form, not to actually distribute this squared. So let's look at this. It says leave is b/2a. Okay, b was 7. So there's my 7 right here. And 2, I have 2 and a. Well, a was 6, right? So what's 2 times 6? It's 12, isn't it? So do you see that this 12 is really the same thing as 2a? Okay, so part 3b says add this to both sides. So I had x squared plus 7/6x. I'm going to add 7/12 squared to that side. If I add something to the left, I better add it to the right. Okay. So then part 4 says, well, we're just going to factor the left-hand side. So we're going to factor this. I don't know how to factor that nicely off the top of my head. Do you? Luckily, there's a math rule that helps us do this and factor it every single time. Hint, the left-hand side, LHS means left-hand side, factors as x minus b/2a. Okay? Or x plus b/2a, whichever one we have. Okay? So, in our case, we're going to have a plus because our b was positive. So, we'll have x. We're always going to use the sign of the value of the quotient in here. So we're going to take the two things that are being squared. So we have x squared. We're going to rewrite that as an x. We have 7/12 squared. We're going to rewrite this as plus 7/12 squared. Okay, so just bear with me for a bit. I will promise I'll prove to you that that is true. So this equals 1/2 plus, I'm actually going to distribute this here. We know that if we have a over b to the n, that's the same as a to the n over b to the n. So this is like 7 squared over 12 squared. Well, 7 squared is 49. 12 squared is 144. Okay, hopefully that's good. So let's just stop for just a moment before we continue, and let's hopefully try to convince you that this expression right here with these three terms factors as this binomial squared. So let's do this off to the side. This is the scratch to check the factorization. So how do we check it? Well, we're squaring it, right? So if you're squaring something, we're going to take this and we're going to multiply and get that. So if you're squaring something, you can really write it by, side by side twice and then FOIL it, right? So we're going to FOIL it. First, we get x times x is x squared. Outer, we do x times 7 over 12, so we get plus 7 over 12x. Inner, 7 over 12 times x. And last, 7 over 12 times 7 over 12. Well, isn't that the same as 7 over 12 squared? And look at the middle two. We can combine those, right? So we get x squared plus, well, when you add fractions, you need a common denominator. Do we have one? Yes, they both have 12 as the denominator. So you rewrite the denominator and then you add the numerators. Well, 7 plus 7 is 14, so we get 14 over 12 times x. Wait a minute, that's not what we had earlier, is it? We didn't have 14 over 12. What did we have? We had 7 over 6. Can I reduce this? Yep. If I divide the top and the bottom by 2, don't I get that 7 over 6? I do. So hopefully, maybe you'll believe me, that if you have something like this, it is the same thing as this factorization. So if you do this process, and you take 1/2 of the coefficient of x, and then you square it and add it to both sides, you can always factor this way. You take the two things that are being squared and you drop them down like this. Okay, let's continue. So we have x plus 7 over 12 squared equals. Well, over here, we're trying to add fractions, so we really need a common denominator. Okay, so it would be really nice if they had the same denominator. I'm going to write over here, right with a little bit of space. The least common multiple of the denominators is 144 because 144 has 2 as a factor, right? So 2 times 72 is 144. So here I can multiply the bottom by 72 and the top by 72. That way I'm multiplying by the number 1, right? If you have an expression, you're allowed to add 0 or multiply by 1. So left-hand side is still x plus 7 over 12 squared. But this piece right here, now we're multiplying fractions, top times top over bottom times bottom. So 72 over 144 plus 49 over 144. Now I can combine these fractions. They have the same denominator, right? I needed a common denominator. Now I have it. So x plus 7 over 12 squared equals. If you're trying to add fractions and you do have a common denominator, you rewrite that denominator and then you combine the numerators. So we get x plus 7 over 12 quantity squared equals 121 over 144. I want to solve for x though. So when I solve for x, I didn't write it here, but I'm going to use that square root property. Which means I'm going to take a square root of the left-hand side and the square root of the right-hand side, remembering to do plus or minus. So when you take a square root of something squared, they cancel each other out because they're inverse processes. So you're left with just the radicand, which is x plus 7 over 12. And then on the right-hand side, we have a square root of a quotient or of a fraction, if you want to call it a fraction. we have a rule that says that if you have the square root of a over b, that's the same thing as the square root of a over the square root of b. So we can rewrite this as plus or minus square root of 121 over the square root of 144. Hopefully you remember that the square root of 121 is 11 and the square root of 144 is 12. We need x by itself, so we're just going to move that 7/12 away. So we're going to subtract 7/12 from both sides. So I'm going to do it on both sides like this. I like to usually put it in front because typically when you see your answer, you have some number plus or minus something else. So usually put it in the front. So we get x equals negative 7 over 12 plus or minus 11 over 12. Again, we have that common denominator. So we rewrite the denominator and we combine the numerators. We have to be careful though, right? This is negative 7 plus or minus 11 over 12. But we really can clean this up. We can combine negative 7 and 11, either adding or subtracting, whichever one we're looking at. So we really need to do that. Let's break this up into two pieces. So there's going to be two solutions. We're going to have x equals negative 7 plus 11, divide the whole thing by 12. Or x equals negative 7 minus 11, divide the whole thing by 12. Negative 7 plus 11 is 4, so we have x equals 4 over 12, which we can reduce, that's 1/3. And here we have negative 7 minus 11, which means we add the numbers and keep the sign. So we have negative 18 over 12. And then if we look at negative 18 over 12, both of them are divisible by 6. So 18 divided by 6 is a 3. We keep the negative sign. 12 divided by 6 is a 2. So the answers are x equals 1/3 or x equals negative 3/2.